Hello students, welcome to ACE Online. In this live, we are going to discuss about GATE 2026 Score Booster series, in which we are going to solve numerical answer type and multiple select question. So you all know in the recent years NAT and MSQs, there are more NAT and MSQ questions appearing in the GATE exam. So today in this live, I'm going to solve questions from engineering mathematics like this. We are going to deal each and every subject in which we will discuss with you the numerical answer type and the MSQ questions. So before I proceed, let me just verify with you people, is the audio, video and the screen clear? So can you please reply? Just confirming it. Students, hope the streaming is going well. Can you people reply so that I can continue this session? Yeah. So I've got a reply from Gaurim, yes, Warrior, Vignesh, yes. So I can continue. So you all know numerical answer type. Like, what are numerical answer type questions? So they'll give you a question and then they'll leave a blank. It's like you have to apply some formula there or some concept, solve it, get a numerical value or a real number, and then fill that real number using the virtual keyboard. In that process, you might need to use virtual calculator also. So you should get used to these kind of questions. So you should know how to round off the numerical answer type questions. Whatever you answer, your answer should be within the range. So those kind of skills you need to develop. Now when it comes to multiple select question, which is in short called MSQ, so where for a question you will have at least one correct answer. So what do you mean by at least one correct answer? You can have one correct answer or more than that. So there are situations, where in the GATE exam, they gave the question says it's a MSQ where they surprised the students with only one correct answer. So students, what they do is the moment they feel it's MSQ, so they are expecting multiple correct answers. They have trapped many students this way, they say it's a MSQ, but they give you only one correct answer. There are MSQs which two correct answers, three correct answers, but I'm just telling you there are situations where an MSQ had only one correct answer. So ACE Engineering Academy wants to train the students, wants to give them the best possible things for their GATE preparation, where we come up with NAT and MSQ questions. So we conduct this live every day. So I'm going to give you the schedule first, and then I'll get into the discussion of NAT and MSQ questions. So look at this poster, GATE 2026 Score Booster series. So it's starting from today, where we solve NAT and MSQ questions. These are the branches: EC, electrical, computer science, mechanical, civil, data science and instrumentation. So every day it is from 7 p.m. onwards. So for computer science, this is the schedule. So you have to follow this. You can see all the subjects are covered here. For data science and artificial intelligence, this is the schedule. Again, all the subjects are scheduled here. So please go through it. For electronics and communication, the schedule is like this. So again, you can see all the core subjects are also included here. So next, electrical engineering schedule is here, and then followed by mechanical engineering and the civil engineering schedules. You can go through it. Once the live completes, you can go to the schedule, and this is the civil engineering schedule. So once again, let me tell you the importance of NAT and MSQs. In the recent time, there are more NATs and more MSQs asked in your GATE exam. So the more you practice, the more marks you can score. And please be aware that NAT and MSQs do not contain any negative marks. So that is one advantage with this question. MSQs have a negative marking, but NAT and MSQs do not have negative marking. I hope you're all ready for this score booster series. So I can see this. So all are saying the video and the audio is clear. So let's begin this. And let me also introduce myself. I'm Aditya, faculty at AS Engineering Academy. I've been training students who are preparing for GATE, ESE and various other exams. So let's look at this question. Consider the given system of linear equations for variables x and y, where k is a real valued constant. Which one of the following option or options is are correct? So the moment I see option or options is are correct, it means it's a MSQ, multiple select question. They gave two equations and they gave various options. So now for a GATE aspirant, a question with two variables or two equations in two variables, they say, Array, this is a very simple question. This is what asked, or this is going to be asked in the GATE. But see the options, when you look at the solution, the analysis that has to be done in this MSQ, you will understand what kind of questions are asked in the GATE exam. So the two variables, two equations in two variables are given. It says there is exactly one value of k for which the above system of equations has no solution. The keyword here is no solution. So you need to recollect when do you get no solution. There exists an infinite number of values of k for which the system of equation has again no solution. So these two options are related to no solution only. Maybe if this is true, this is false, or if this is true, this is false, something like that. There might be some relation between them. There exists exactly one value of k for which the system of equations has exactly one solution. There exists exactly one value of k for which the system of equations has an infinite number of solutions. So what shall we do? So I stick to the basics. I write the augmented matrix, convert the augmented matrix to row echelon form. So what is the augmented matrix here? It is 1 k1 k1 minus 1. So let's convert this to row echelon form. So for that I'll write like this: R2 replaced with R2 minus k into R1. So the idea is very simple. Using this element, make this element 0. So you're all aware of that. So you get new elements. So what are those new elements? The first row remains same, 1 k1, and then it is k minus k is 0, and then 1 minus k square is 1 minus k square minus 1 minus k. So this simple augmented matrix can solve or can help you to solve the entire question. So keep this as a reference and then start answering about ABCD. This will be a good reference for us to answer or to verify options ABCD. So let's start with option A. There exists one value of k. There exists exactly one value of k for which the system of equations has no solution. Okay, so I'm highlighting here. I'm looking at option A where they talk about no solution. So you need to recall, so when do you get no solution? So it happens when rank of AB is not equal to rank of A. So we need to meet this rank of AB not equal to rank of A. It leads to no solution. So how many such k values can lead to no solution? That's the question. So what is my intention is I want to make rank of AB 2, rank of A as 1. So I want this element to be 0 and this to be non-zero. So this to be non-zero and this to be 0. So clearly I have a choice. For k equal to 1, let me substitute. What do I get? 1 1 1 0 0, and then minus 1 is minus 2. So clearly what is rank of AB? Rank of AB is 2. What is rank of A? It is 1. So what happened? No solution. So far, how many such k values you got? I have got only one k value so far. Let's search for a few more. So the idea is, I want this to be 0 and this to be non-zero. That's when the rank of AB will be 2 and the rank of A will be 1. So when will this be 0 and this non-zero? So basically this is 0, 1 minus k square. When is 1 minus k square 0? It is for k equal to plus or minus 1. There are only two values of k for which this quantity would be 0. I have already analyzed k equal to 1. If you try to analyze for k equal to minus 1, this would be 0 and this will also be 0. So when this is also 0, this is the entire 0 row. This doesn't lead to no solution. So far I found only one such k value which can give rise to no solution. There is no doubt in this. This is a true statement. And then there exists an infinite number of values of k for which the system of equation has no solution. Just now I said there exists exactly one value of k, and in option B it says infinite number. False. This is a false statement. So with this we have analyzed two options. So that's how the MSQs are, right? They might be simple two equations. See how much analysis is needed in the background. When you practice this kind of models, that's when you get a confidence in the exam, yaar. There exists exactly one value of k for which the system of equations has exactly one solution. So let's go to the next slide. So what's the discussion about? The discussion is about exactly one solution. Exactly one solution means unique solution. Exactly one solution. When do you get this? This happens in the case of rank of AB equal to rank of A. Equal to number of variables. Here number of variables are 2. So we want rank of AB equal to rank of A equal to 2. That's when you will have exactly one solution. What he says? He says there exists exactly one value of k which can lead to exactly one solution. My requirement is rank of AB has to be equal to rank of A equal to 2. See, when is this becoming 0? For plus or minus 1. If this is not 0, if this is not some non-zero element, right, then the rank of AB would be 2. The rank of A will also be 2. So what I want? I want 1 minus k square not to be 0. When is 1 minus k square 0? Only for two values. But when is 1 minus k square not 0? For many values of k. If you don't understand, then what you do is take k as 2, 3, 4 and so on. Try to put it here. You get rank of AB equal to rank of A equal to 2. So for unique solution or for exactly one solution, there are actually many values of k. But what is he claiming? That there exists only one such k. So this is false. And then we are left with the last option. There exists exactly one value of k for which the system of equations has infinite number of solutions. So the next discussion is about infinite number of solutions. So let's highlight that the discussion is about infinite number of solutions. So when does this happen? So this happens when rank of AB equal to rank of A less than number of variables. The number of variables in this question are 2. So when will rank of AB equal to rank of A but less than 2? So how many such k values can give this? I want rank of AB equal to rank of A but less than 2. So for that I want this entire row to be 0. When does this entire row become 0? So I have a choice. So maybe when I put k as minus 1, let me check. When I put k as minus 1, what do you get? You get 1, minus 1, 1, and then you get 0, 0, and then it is minus 1, minus of minus 1, it is 0, na? Right. So this is a case where rank of AB is equal to rank of A, but it is equal to 1, which is less than the number of variables. how many values of k gave this? K equal to -1 is giving that. Any other values? No other values, because this is becoming 0 only for plus or -1, and when I put +1, this is 0 and this is non-zero, which is leading to no solution. So there is only one value of k, and that is k as -1, which can give you infinite number of solutions. This is a true statement. So this is the MSQ. What are the correct answers? The correct answers are A and D. So students, I hope you have understood this. So come on, students, have you understood this question? If you have any doubts, you can post it. I'll be reading once I complete the questions. One of the student is asking, will this PDF be provided? Maybe I'll try to upload the PDF, but for that the live has to end, and then we have to upload that PDF. So it's a lengthy process. We will try to upload the PDF after some time. So now the present live is going on. We can't do anything right now. This is clearly a 2-mark problem in your GATE exam. This needs lot of skills, lot of calmness. Let's proceed and then solve the next question. So let's see what does he say in this question. He says there is a n cross n matrix A. There is a n cross n matrix A with real entries which satisfy the property the norm of ax whole square equal to norm of x square for all x belonging to R power n, where this notation is nothing but the Euclidean norm. Which of the following statements is are always correct? So again, it's a MSQ. Students, you should know what is this Euclidean norm. So let me explain you about what is Euclidean norm, and then I'll come back to this question. Suppose if I give you a vector like this, I ask you what is its Euclidean norm. Basically, it's like you are finding the length of the vector from origin, or in simple words, it's a distance from origin to that point. So how do you find it? It is root of 1 square plus 2 square. So this is called basically the Euclidean norm. Now what they gave is norm of ax whole square is equal to norm of x square, and there are multiple ways to find this. Suppose if I ask you what is norm of x square, then this is like 1 square plus 2 square, like you are squaring, the square root cancels. I can also find the norm of this vector like this is the norm, by saying x transpose into x. This is called the dot product basically. So when you try to find the dot product of, or when you try to find x transpose x, let's see what happens. X is like a column vector, x transpose will be like a row vector. This is 1 2, and then x is like a column vector. This row into this column will give you 1 square plus 2 square. So you should know a fact that norm of a vector square is simply x transpose into x. If you know this logic, you can easily solve this question. Let's write the first point, the first condition that he gave. So what he gave, ax norm square is x norm square. Just now I said, how do you find the norm square, Euclidean norm square? You take x transpose x, that is nothing but the norm square. So this part can be simplified or can be rewritten as x transpose x. Then this ax is a vector, na? Then this also is written as ax transpose into ax. How is this written? It is written as ax transpose into ax. And we know what is ax whole transpose. Ax whole transpose is x transpose a transpose, and then you again have a, and then you have x equal to x transpose x. We want LHS equal to RHS. So when is LHS equal to RHS? Let's ask the students, when is LHS equal to RHS? Can anyone answer this? Can anyone answer when will this LHS be equal to RHS? I'll wait for 10 seconds to see what is your reply. So I haven't got any reply. Yeah, I got the reply. Uh, Pradhan says A transpose A equal to I. And Harshit says when A into A transpose is equal to identity. Praveen says some identity matrix. Yes, you are all right. So now when is this equal to this means it is when A transpose A equal to identity matrix. So that means what? Clearly the matrix A satisfies A transpose A equal to I. That means A is orthogonal. Any matrix, any square matrix which satisfies A transpose equal to I is called a orthogonal matrix. So A must be orthogonal matrix. This is the true statement. Likewise, you have to read the other options as well. B, option B, it says A equal to I, where I denotes the identity matrix, is the only solution. No, it can be any orthogonal matrix. Identity matrix, A equal to identity matrix is one of the solution. There can be other orthogonal matrices which can satisfy A transpose into A equal to I. So this is not always true. This is a false statement. The eigenvalues of A are either 1 or -1. This is also a little critical point. Now I have studied that the eigenvalues of an orthogonal matrix have absolute value as 1. What I have studied is they have an absolute value 1. So let me give you one important example. If you look at one of the frequently used orthogonal matrix examples, so this is cos theta minus sine theta, cos theta. By now you should have analyzed what are its eigenvalues. The eigenvalues of this matrix are in the form of cos theta plus or minus I sine theta. This is basically a orthogonal matrix, students, whose eigenvalues are complex, and when you try to take the absolute value, it is root of cos square plus sine square, which is always 1. So what he says is the eigenvalues of A are either +1 or -1, but I found that an orthogonal matrix can have cos theta plus or minus I sine theta. Like these kind of eigenvalues are also possible. This need not be true always. This is false. Now coming to the option D. So the determinant of orthogonal matrix. The determinant of an orthogonal matrix, I think it is either 1 or -1. But sure, I can tell you that the determinant of the orthogonal matrix is never 0. The determinant of the orthogonal matrix is never 0. So what? When the determinant of a square matrix is non-zero, it's a full rank matrix. So if it's of order n, the rank is definitely n because it is non-singular. So this is true. So we got the correct options and the answers are A and D. So the answers are A and D. Students, let me also share one important information with you. You can go and check any gate paper from the point of from the time of where MSQs are introduced. I found one nice statistics. I never found an MSQ where all ABCD are right answers. You can go and check from 2022 onwards. I have never seen an MSQ having all ABCD as right answers. I have seen MSQ with only one correct answer. I have seen MSQs with two correct answers. I have seen MSQ with three correct answers, but I have never seen an MSQ with four correct answers. You can also verify this data. Okay. Praveen says, can you explain us option B once again? Okay, option B. Uh, A equal to I, yes, is one of the solution, but A equal to I is not the only solution. Apart from identity matrix, there are other matrices A which can satisfy this. I accept that A equal to I is one of the solution which will satisfy this, but he's saying A equal to I is the only solution that is possible. No, I don't accept. There are orthogonal matrices for us which can satisfy this. Hope Praveen has understood this option B now. Okay, so let's continue. So let's see what is this problem about. Since there are three boxes containing white balls and black balls. Box 1 contains 2 black and 1 white. Box 2 contains 1 black and 2 white balls. Box 3 contains 3 black and 3 white balls. In a random experiment, one of these boxes is selected, where the probability of choosing box 1 is 1 by 2, box 2 is 1 by 6, box 3 is 1 by 3. A ball is drawn at random from the selected box. Given that the ball drawn is white, the probability that it is drawn from box 3 is dash. Okay, so I'll give you 1 or 2 minutes for you to read and understand. If possible, try to comment, and meanwhile I'll be reading your comments. Okay, so the streaming is going well. So let me explain this. You can take a minute time to read this question. Try to understand this. This is related to conditional probability and Bayes rule. So finally what they want, given that the ball drawn is white, the probability that it is drawn from box 3. So it's a one line answer, students. Those who practice conditional probability and Bayes rule in a proper manner, for them it's a one line answer. It's already given the ball that is drawn is white. What is the probability that it came from box 3? So this is the question. Now why don't you ask a question like this? When can you draw a white object? If you can write like what's the probability of drawing a white object here, the problem is completed. If you can write the probability of drawing a white object, the problem is almost over. So I'm trying to see like when can the ball be a white object. So is it possible through box 1? Yes. If I select box 1, from that can I get a white object? Yes. Or, now see the way I'm using the word or. It is either from box 1, the white object can be drawn from box 1, or from box 2, or from box 3. So if I select box 1, yes, I can get a white ball. Or if I select box 2, I can get a white ball. Or if I select a box 3, I can get a white ball. If you can write the total probability, this is called the total probability, then it's a one line answer. So let me select box 1. Here box 1, box 2, box 3, they are not equally likely. Selecting box 1 has a probability of how much probability? 1 by 2. Box 2 is 1 by 6. Box 3 is 1 by 3. So what is the probability of selecting box 1? It is 1 by 2. So now which box did you select? Box 1. Which box did you select? Box 1. Now from that I need a white object. The total objects in box 1 are 3 and there is only one white. So what's the probability of drawing a white object? It is 1 by 3. So this is the probability of drawing a white from box 1. But a white ball can be drawn either from box 1 or from box 2 or from box 3. So the moment you use or, it's the addition. What's the probability of choosing box 2? It is 1 by 6. So now what did you choose? Box 2. So let's go to box 2 description. Total there are 3 objects in which 1 black and 2 white. So from box 2 I need one white object. What's the probability of drawing a white? It will be 2 by 3, and it can also be from box 3. So what's the probability of choosing box 3? It is 1 by 3. So now you have selected box 3. Box 3 has total 6 objects and I want a white object. The probability of choosing a white object is 3 divided by 6. This is called the total probability. If you can write this with full confidence, the problem is completed. Now among these 3 terms, 1, 2, 3, which is related to box 3? Which is related to box 3? This is the term which is related to box 3. Now you simplify this, get a decimal value and then round off to 2 decimal places. Can I expect a decimal value in the chat? Come on, take down this. See what could be the decimal value. I'll be waiting for your reply. So Ramu says it is 0.375. Shiva says it is 0.37. Okay. Kuruva says 0.37. There are many students who are hitting the same answer, that is 0.37. Since they said round off to 2 decimal places, maybe if it is 0.375, okay, 0.37 looks okay for me. Suppose, yeah, 0.37. I think the exact answer is 0.375. Even if you answer like the 0.375, there is nothing wrong in it. So let's proceed. Bukya Sirisha says, can you explain it once again? Definitely. So you have to read the question like this. It's already, they have drawn a white object. Given that you have drawn a white object, what's the probability that it came from box 3? So like I'm asking you, what's the probability of drawing a white object? So from where can the white object can come? It can come from either from box 1 or from box 2 or from box 3. So this is the probability of drawing white from box 1. This is the probability of drawing white from box 2. This is the probability of drawing white from box 3. So once you write this, which term is related to box 3? You put that in the numerator to get this kind of conditional probability value. So this is related to conditional probability and then Bayes rule, a very interesting problem. You can see it can be solved in one line. Since they say round off to 2 decimals, yes, it is 0.37 is the right value. Bukya Sirisha, hope you have understood. If you want further explanation, like I want to first select box 1. Selecting box 1 probability is 1 by 2. Once I select box 1, from box 1 I need a white object. So it is 1 among the 3. So 1 by 3. Selecting box 2 is 1 by 6. In box 2 I want to pick one white object. Total are 3 but favorable are 2. So it is 2 by 3. Box 3 probability is 1 by 3. If you examine box 3, there are total 6. 3 are favorable, so 3 by 6. I hope this is now clear. So let's proceed. Again, this is a fantastic question. So a lot of depth is there in this. So slowly we will try to understand this. A ball contains 5 white balls and 10 black balls. Okay. There are 5 white, 10 black. In a random experiment, n balls are drawn from the back one at a time with replacement. How many objects are drawn? N objects are drawn. How are they drawn? One at a time with replacement. That means you draw one object, you will notice what kind of object it is, what kind of color it is. You will put it again in the bag. So if there are n objects in the beginning, after the first row again there are n objects, because after you draw you are again placing it in the back. Let Sn denote the total number of black balls drawn in the experiment. Okay, so we don't know what is n. This is Sn. Since you are drawing n objects, Sn is talking about how many were black. So Sn denotes the number of black balls drawn in the experiment. The variance of S99 is denoted by variance of S99, and they want the variance of S99. When you read this question, majority of the students would have not understood this question. Maybe they have understood up to this point. Like there are 5 white objects and 10 black. They are drawing n balls. By the way, in the question, Sn and here S99. So what is n? N is 99. So now how many balls are drawn means 99 balls are drawn. You might ask, sir, here 5 white and here 10 black, total 15 are there. How come you are drawing 99 balls? When there are only 15 balls given, how are you able to draw 99 objects? This might be a question in the student's mind. Students, yes, there are 5 white and 10 black, but how are you drawing the objects? You draw one object, you look at its color and you will place it back, and you are repeating this 99 times. You are repeating this how many times? 99 times. So how do you solve this? Whenever I try to pick a object, when I perform this trial, it is either white or black. It is either white or black, and it is repeated how many times? 99 times. So something like this is a failure and this is like a success. There is one random variable which deals with this kind of outcomes. If an experiment has only two possibilities, namely failure and success, and if you repeat that experiment n times and you start counting the number of success, the number of success is now a binomial random variable. I once again repeat, whenever you try to pick one object, it is either white or black. It is either failure or a success. And you are repeating this how many times? 99 times. So maybe first I have to give you a recap of what is a binomial random variable. What is a binomial random variable? In binomial random variable, you perform an experiment n times. There are two things, one is called n and other is p. There are two parameters in binomial random variable. One is n, other is p. N is the number of times you repeat that experiment. P is probability of success. So what are you doing is you are counting the number of success. The number of success is represented as x, where x can take values 0, 1, 2 up to n. You can give its mass function. Here I don't need the probability mass function, but I need to know what is its mean. Mean is also not needed, just I'm writing for your revision purpose. It is np. So now the most important thing that I need is variance of x. Variance of x formula is np into 1 minus p. np into 1 minus p. This is variance of x. This might be very useful for us now. In the present problem, you know what is n? 99. What is n? 99. So in the present problem, let me highlight that n value is 99. What is Sn? It is trying to count the number of black balls that are drawn in the experiment. So I think I have to write like this. S99 is a binomial. It is a binomial random variable with parameters n as 99 and the probability of success, that is the probability of drawing a black object every time. So every time in the bag there are 5 white and 10 black. What's the probability of drawing the black object? The probability of drawing a black object is there are 10 favorable balls, there are 10 black balls among the total 15. So the probability of success is 2 by 3. So S99 is a binomial random variable with parameters n as 99 and the probability of success as 2 by 3. This completes the problem. So what is the variance of a binomial random variable? What is the variance of binomial random variable? The formula is np into 1 minus p. What is the value of n? 99. What is p? 2 by 3. What is 1 minus p? 1 minus 2 by 3 is 1 by 3. 3 into 3 is 9. This cancels 11 times. I think yes, 9. 99 by 9 is 11 and 11 into 2 is 22. So what's the variance, students? It is 22. The variance of S99 is now 22. So please go through this. This is a beautiful problem on binomial random variable. Here Sn is a binomial random variable with the parameters n comma p. They gave n as 99 and p is nothing but the probability of drawing a black object, because Sn denotes the number of black objects that are drawn. So a fantastic problem. So hope you are all following this. This is a very tricky question. Those who know binomial random variable in a proper way, those who have learned, those who have not just memorized those formulas, those who have understood what actually is a binomial random variable can solve this. So let's continue with few more questions. So what are they asking here? Let x be a random variable which is exponentially distributed with parameter lambda greater than 0. So the discussion is now about exponential random variable. The probability density function of x is given by lambda e power minus lambda x. Okay, we all know for exponential random variable the probability density function is lambda e power minus lambda x. Do you know its mean? Yes, 1 by lambda. Do you know its variance? 1 by lambda square. They give a condition 5 into expectation of x is equal to variance of x, and then they want the probability of x greater than 2. So they want this value round off to 2 decimals. How do you solve this? Do you people know? First of all, it is 5 into expectation of x equal to the variance of x. What is expectation of a exponential random variable? It is 1 by lambda. What is variance of exponential random variable? 1 by lambda square. You can cancel out, so you will have 5 equal to 1 by lambda, which means lambda is 1 by 5. 1 by 5 value is 0.2 na? Are they asking lambda value? No. This lambda value will be useful for the next calculation. So we have extracted lambda. What next? Students, whenever a question is framed on exponential, so most of the time they use this result, if x is exponential random variable, then the probability of this event is one of the most important things. You can write the answer in one line. The probability of x greater than k is simply e power minus lambda k. E power minus lambda k. Now what is asked is the probability of x greater than 2, which is e power, in the place of k put 2, so it is e power minus 2 lambda. And then we have just now extracted lambda, so this is e power minus 2 into 0.2, which is e power minus 0.4. Now you have to use the virtual calculator, get the decimal value for this, and then round off to 2 decimal places. I'll be waiting for your reply. Let's see how many of you will give the same answer. So for that you have to open the virtual calculator. So let's see whether I can open it here. So using the virtual calculator is very important, students. So you should get used to virtual calculator. So what I need? I think e power minus 0.4. So look at the way I find it. So first I put minus 0.4 and then I have to take it to the exponential. So this is e power minus 0.4, which I got as 0.6703, and he says to what, up to 2 decimals. Up to 2 decimals, I think it is 0.67. Did anyone get this kind of value, 0.67? Anyone? Bhaskar, Lakshmi, Shiva, they have replied 0.67, and I have also got this. So through this, you are also using virtual calculator. Those who are not practicing virtual calculator, for them in the GATE 2026, the actual exam, it would be a nightmare. So see how effectively I have done, because I frequently use virtual calculator. I did not stop, I did not search for where is e power x, where is log x, and so on. Praveen, your answer is not matching with my answer. You can check the calculations. Okay. Let x be a random variable which is uniformly distributed in the interval 1 to 3. Y be another random variable which is also uniformly distributed in the interval 2 to 4. If x and y are independent of each other, then the value of variance of x minus y rounded off to 3 decimal places. Clearly, we are discussing a case where x and y are independent. When x and y are independent, this is a surprise formula, you know. The variance of x minus y is variance of x plus variance of y. The actual formula is variance of x plus variance of y minus 2 into covariance of x comma y. But in the case of when x and y are independent, we have this covariance to be 0, and then this formula reduces to variance of x minus y equal to variance of x plus variance of y. It reduces to this. Some students by mistake they put variance of x minus variance of y. No, it is variance of x plus variance of y. Now the discussion is about uniform random variable. So if you have a uniform random variable in the interval a to b, can you recollect what is variance formula? It is b minus a whole square by 12. It is b minus a whole square by 12. So what is variance of x? It is 3 minus 1 whole square by 12. How much is this? Difference is 2. 2 square is 4. 4 by 12 is at 1 by 3. What is variance of y? Again the same formula, b minus a whole square by 12. So it is 4 minus 2 whole square by 12. Again the difference is 2. 2 square 4. 4 by 12 is 1 by 3. So now I have the variance of x and variance of y, which is like 1 by 3 plus 1 by 3, which is 2 by 3. 2 by 3 value 0.666, so on. And he says round off to 3 decimals. So when you round off to 3 decimals, will the answer be like this, 0.667? This is the right way to round off, 0.667. What, students? Have you got this idea? So again, here uniform random variable, those who know what is uniform random variable, for them, like if you know the formula and you know what is variance of x minus y, for them it's a simple task. So this is a time where you have to revise, you have to solve the problems quickly, accurately. So let's proceed. So this question is about the limits, where they are asking limit extends to 0 log 1 plus x minus x plus x square by 2 whole divided by x cube. So what we usually do, substitute the limit. When I substitute the limit, I get log 1 minus 0 plus 0 by 0 cube. So this is 0 by 0 form. And you know what to do next. You will use L'Hospital rule and then you try to simplify it. That is one way. The other way is those who know the Taylor series expansion of log 1 plus x. Those who know what is log of 1 plus x, they might save some time. Log 1 plus x expansion is it is x minus x square by 2 plus x cube by 3 minus x power 4 by 4 and then so on. This is log 1 plus x minus x plus x square by 2 and then whole divided by x cube. Do you have any terms getting cancelled? This and this cancels, this and this cancels, and then you are left with x cube, x power 4 and so on, where every term is either having a power 3 or more than that, which clearly suggests that I can take x cube common and then I can cancel with the denominator x cube. So when x cube is taken common, 1 by 3 minus what, x by 4 plus x square by 5 and so on by x cube. This cancels, and when I try to apply the limit, when you try to apply the limit, now all these terms go to 0, you are left with 1 by 3. What is 1 by 3 decimal value? It is 0.3333 and so on, and he says round off to 2 decimals, so the third decimal is 3, so it is 0.33. This is the answer for this question. So here should know the expansion of log 1 plus x. So these kind of things are very useful in the exam. I hope you're all following this live. So let me solve one more. Let me solve this. In this question, he wants the maximum value of this function in this closed interval, right? So it's a closed interval problem. Now when you are given the closed interval, it's very easy, you know. So what you have to do is, let's find f dash. It is 8 by x minus 2x, that's it. Equate this to 0. 8 by x minus 2x equal to 0, and then 8 by x equal to 2x. You have 4 equal to x square, is it? And then you have x value as plus or minus 2. You can ignore minus 2 because minus 2 is not in this interval. So you have x equal to 2 as the valid point, valid stationary point. You need not do any second derivative thing here. What you do is find the function value at these endpoints as well as at this stationary point. Like I'm asking you, what is f of 1? Find it. What is f of 2? If you can find what is f of e, this will give you the answer. That is that much simple because it's a closed interval problem. So this is what we do in the closed interval. What is f of 1? Log 1 is 0. So 8 into 0 minus 1 square plus 3. This is 0. 3 minus 1 is 2. F of 2. 8 log 2 to the base e minus 4 plus 3. This is 8 log to the base e minus 1. F of e. Log e to the base e is 1. So this is 8 minus 4. Oh, not 4. It is e square and then plus 3. So this will be like how much? 11 minus e square. Anyway, I know this as 2. Now you people will have to find this decimal values. Can you provide this decimal values? If you can provide, I can pick the maximum value of this. So I'll be waiting for your replies. So Akshat says, how long will this session go on? It is from 7 p.m. to 8 p.m. every day, 7 p.m. to 8 p.m. So tomorrow also you will have the session. So we have clearly given in the beginning of this live, I've given a schedule. So Akshat, you can follow that schedule accordingly. You can attend this. Can you people provide the decimal values for this? Let me also find it meanwhile. 8 log. So log to the base e, which is ln. So 2 ln. So this is now log 2 into 8. So what next? Minus 1. I got 4.54. 4.54. Okay. And then 11 minus e square. You can take some more decimals if you want. In the question I did not mention how many decimals. So 3-4 decimals if you take, it would be good. So I have taken up to 4.54. Now I want 11 minus e square. 11 minus and then e square and then equal to 3.61. 3.61. Now if I examine this, clearly the maximum value is 4.54. Suppose if in the question I say round off to 2 decimals, the answer should be 4.54. 4.54. So I hope you people have got this idea. Harsh says, can you provide us the PDF of this? I'm not sure, Harsh. I will try to provide it. I have to complete first this live and then save this. We will try to give it to you. We will, if possible, I will try to attach this PDF in the description. So once this live gets over, if you can give me some time, maybe one day, I'll attach this PDF in the description. You can, through that link, you can download the PDF. I have a few more important things to share with you. So this is a really good news for you people. So what are those things? ACE Engineering Academy is conducting pre-gate exam, which is on 18th January. The last day to register for this is 16th January, where you can scan this QR code and you have to complete that registration process. These are the session details. Now, why is this pre-gate exam important? This is not like a regular mock exam where you can write whenever you want, whenever you are leisure. No, this exam is fixed. You have to write from 9:30. For example, for civil and instrumentation, the exam starts at 9:30 and then ends in 3 hours. So you get the exact experience of the gate exam. So you'll know how to manage the time there, right? So, and you cannot, if you want to write some other day, it's not possible. And also, once the exam gets over, we will declare the results. You will know where you will stand in the all India level. Various students from the entire country appear for this. So when you write, when you check your results, you will know if any minor corrections are to be made, some revision has to be done, you can do it. So there are many advantages of writing this pre-gate exam. You have to scan this QR code, complete the registration process. And then we are announcing this GATE 2026 revision series. So it starts from 10th January for these branches: civil, mechanical, electric, ECE, electrical, computer science, and DA. To get this revision series, again you have to scan this QR code, complete that registration process, and in this revision session we cover all the subjects from engineering, mathematics, aptitude, verbal, all the core subjects, right? It gives you a quick recap of all the topics. This is very useful for your last minute preparation. So our classroom students, or those whoever have enrolled our classes, they need not scan this. For them it will appear in their schedule. So it is for the new students who wants to take up this, especially who are in the third years, who are in the fourth years, who wants to give a try at the gate exam. So those who are in need of that revision, we are there to help you. And I have also a coupon. I just want to share that information with you. So we have this gate 26, this coupon gate 26. If you use this gate 26 coupon, then you get a 30% discount on this. Those who have registered, those who are our current year students, they need not register this. For them, we are providing for free. The schedule will be updated for them. They can join us. This is for the new students. Who has to register? Those who are in the third, fourth years, who have not taken any coaching. They want to give a try at the GATE exam, which is the most prestigious exam, which has got PSUs linked to it, which has got MTech programs linked to it, which has got research programs, PhD programs linked to it. So if you want to check where do you stand and you want help in the form of a revision series, so we are launching this. This starts at 10th January. So where we teach, where we recap the entire subject. All the subjects will be revised. So this will be very useful for the students. And I hope this series, the GATE booster series, I hope it will definitely help you. If you have any doubts, you can ask me now. I'm there to help you. I'll be ending this live in a few minutes. If you have any doubts, you can ask. So tomorrow also, I'm here taking engineering mathematics for DA students, data science and artificial intelligence students. So those students can join me tomorrow. Every day with new subject. Like I have given you the schedule as well. You can see in the beginning, I have given you the schedule. So this is the schedule for various departments, various branches. You stick to this schedule, and then this is definitely useful for you. Any other things? So there is a student who says, can we get at least 5 to 8 marks in mathematics if we start preparation now? Yes, you will definitely get. Engineering mathematics and aptitude are considered to be high scoring. So they are almost like for 28 marks. You take any student, the majority of the marks they get from aptitude and mathematics. So this has to be your scoring. For that, you have to solve. First, you have to prepare all the topics, solve the previous year questions, 2025, 2024, 2023. The last 10 years of PYQs, if you can solve, write mock exams, you can easily get this. And you can post your doubts. Once this live gets over, in the comments also you can post. Every day we are here to guide you. You watch our live programs, we will help you. So yes, that's it for today. We'll come with new questions like NAT and MSQ every day. This will be useful for you. And I want you people to share with your friends also, those who are in third and fourth years, who are preparing for the GATE exam, or those who have taken the long term, or those who are preparing on their own. You share this live details with them. It will be useful for them as well. So thank you students for being with us.